Hello. In this video, we'll learn how we can mesh two bevel gears in Creo and establish a gear connection between those two bevel gears so that when we spin the first bevel gear, the second bevel gear, which will be connected perpendicularly, is spun and power is transmitted across 90 degrees through the bevel gears. This is very similar to what we've done previously for a spur gear train, but a spur gear transmits power across horizontal shafts, and bevel gears can be used to transmit power across perpendicular shafts normally, even though there are specialized bevel gears that can transmit power across intersecting shafts at 45 degrees or 120 degrees or even non-intersecting shafts. But we are focused on the standard case where we will have two bevel gears transmitting power across 90 degrees. You are welcome to design your bevel gear yourself. You'll use standard operations whereby first you'll make a cone because the base of a bevel gear is a cone, whereas the base of a spur gear of or a helical gear is a cylinder. Make a cone, then remove material from it to make your involute profile, and once you have a tooth you can pattern it axially about the center of the uh, of the gear, and you'll have your bevel gear. But what I'll do is that I'll use bevel gears, standard bevel gears which have been made by uh, manufacturers, which are sold on McMaster-Carr. We've talked about McMaster-Carr. It's an online hardware store, and I'm sure that you can get to this page. If you can't, there's the link over here. Uh, and I will be choosing this bevel gear from here, and I'll try to mate them together like such, and then on actuating the first gear, the second gear should move perpendicularly. A few important parameters of this gear: like with spur gears, two mating gears should have the same gear pitch and the same pressure angle. In my case, it doesn't really matter because for the sake of example, I'm going to use the same bevel gear twice. So all I'm doing is changing the direction of motion. I'm not changing the speed of the outlet relative to the inlet. But if you are using gears of two different sizes, make sure that the gear pitch and the pressure angle are the same. Right now they are the same because I've applied this filter over here where only those gears with the gear pitch of 12" is being shown. And the second parameter that is of importance to us is this mounting distance. So for each bevel gear, if you draw a cone along its teeth, it will intersect at a point along its axis, and that will determine its mounting distance. I was hoping that I'll be able to draw over here. This is more complicated than I thought, but might still work. If you draw a line along its tooth, through its tooth, and see where it intersects its central axis, that is the point where your two bevel gear would meet, where the respective apex angle of the bevel cones for both the gears would intersect. But for us, this has been calculated as the mounting distance. So the mounting distance for our gear that we are using is reported over here as 1.25 inches. So that's the distance from the back of the hub, in this case, to the cone apex point, and the two bevel gears should have the same. They don't have to have the same mounting distance, but if the two bevel gears are identical, then they'll have the same mounting distance. So I'll use this back plate, this base assembly to mount my bevel gear. So I have downloaded my bevel gears from McMaster-Carr by selecting the gear that I want. Let's say that I want this gear, and then select a 3D step file. That's a 3D format. Unfortunately, Creo's part format is not available over here. Download that, and then we can import that in Creo. So I'll open a new part file, and right now the bevel gear which I've downloaded is not visible because it's a step file. You could either enable all files, or if you want to be selective, you can select step file from here if you can find it. Over here it is, and now it will only show you your step files in your working directory. I'll import it, and this step converts the step file into a part file, into a .prt file, so that we can work on it in Creo. You can adjust these settings if you want. You can change the name. I'm happy with the default name. And now it has been opened in Creo as a part file. You'll notice that you have a coordinate system, but you don't have datum planes. And most likely you will need them later. So a very simple way of adding principal datum planes to imported parts in Creo is by going to datum over here and creating offset planes, and this is the offset to the origin of the coordinate system, and we want the x offset to be 0, the y offset to be 0, the z offset to be 0, and it has created three principal planes which are mutually perpendicular and are passing through the center of our gear. We can verify that by looking at it perpendicularly. And another benefit of doing this is that we can now easily create an axis through the center of this gear. Had we created a cylindrical feature in Creo, an axis would have automatically been generated, but over here we don't have an axis. The axis option over here is enabled, but nothing is showing up, and we will need to have an axis in order to define pin joints. So I'll define an axis over here by selecting two intersecting planes, and an axis would be defined at along the line where these two planes are intersecting. So you see a new axis has been created, and that's over here. Another thing that I'll do is I will define this mounting distance. I'll make a point over here so that I know where the mounting distance is, and that's just for reference. So I'll make a sketch over here, and I don't know if we've discussed this previously or not. If you're in the sketching view and you are working on a plane which is in between some material, you can clip the material between your eye and that plane by pressing this clip mode, and it gives you a cross section in that sketching plane. And what I'll do is that I'll just make a simple line starting from the back of the gear ending somewhere over here, and I know that the length of this line, if I want this to be an indicator of the mounting distance, should be 1.25 inches, and I'm working in inches, so I'm consistent in terms of units. And now what I'll do is that I will create a point. Now I'm not in Sketch, I'm in the default model tab, and I'll create a point which is a zero-dimensional datum. Axis is a one-dimensional datum, point is a zero-dimensional datum, and planes are two-dimensional datums. So I'll select the edge of this line and create a point over here. I can actually hide the sketch now, I don't really need it, but this point would be a useful reference later. So this point is the apex, the vertex of a cone if it were to be created by extending these teeth. So if I look at it, normally this will become obvious. So if I look at things perpendicular to this axis, just imagine that you had a line extending through this tooth. Where it would intersect the axis of this gear is this point. So that's the tip of your bevel cone. I'm happy with this bevel gear, which was imported as a step file and has been modified in the part file. I'll assemble that over here. This is the bevel gear that I just imported, and I'll define a pin joint from here. Sorry. The first thing that you need to define is the axis. So select this axis and select the axis on the shaft where you want to mount it. And the second thing that you want is a translational constraint. So what I'll do is that I will select this surface and this surface, and I'll make them coincident for now. It's not realistic, but for the purposes of our demonstration, that's good enough. So that's our first bevel gear. We can verify that it's a pin connection because it rotates and it doesn't translate. Okay. So now we have to add the second bevel gear. And before we add the second bevel gear, we have to have an axis, we have to have a shaft on which to mount it. Let's think about where the shaft would be. So the first thing that we know is that the shaft would have to be on the same plane as this first shaft. So for that, let's create a new plane. You can either work on your base part within this assembly by activating it, or what I prefer, just to keep things less crowded, is to open that file in its own window and then work on it. So what I want is a plane which is parallel to this plane and intersecting this axis. So I selected these two things while holding down control, and I'll make a new plane by pressing the plane button, and I'll have to prescribe a few things. So what I want the new plane to do is not be at an offset from the reference plane. I want it to be parallel to the reference plane. And the second reference that I provided was the axis, and I want the new plane to be passing through it. So that's good. After having fixed these two properties of the new plane, I click OK, and this new plane has been created. As we've discussed previously, you can modify how big or small you want this icon, this representation of your plane to be. So this is more intuitive for me, because if I look at this plane, I'll know right away that this is a plane that I've made in reference to this shaft. So now going back to our assembly, we have this plane. So the next shaft that I'll create would have to be in this plane, and it would pass through this point. So how do we make that that shaft? Let's go back to our base assembly and make a shaft over here by performing an extrude operation. That shaft has to be centered along this axis. It has to be on this plane. So I'll make a circle over here. I don't know why it's not snapping. Hopefully in your case it is, but for me, I know the distance between this plane and the base, which is 1. So I'll manually confirm that, but it should have snapped. And the second thing that we know is that the mounting distance for our case is 1.25, and the back side of the hub is connected, is coincident with this surface of the shaft. So what I'll do is that I'll confirm that this distance is 1.25, and then I'll make a shaft on which I can mount my second bevel gear. Hopefully, once we implement the assembly operations, it will become clear why I did what I did. Let's import the same bevel gear again, and we are again defining a pin joint. We can bring the gear a bit closer. The first thing that we need to define is the axis of the pin joint. We do that, and then the next thing that we need to define is a translational constraint which aligns our gears together. So for that, I'll select this plane, and I'll select the back of my bevel gear, back of the hub, and I'll define a distance, and that distance would be equal to the mounting distance, which is 1.25. I think that was not implemented for some reason. Let me delete this constraint and redefine it. So the part of the component that I want is this, and I want it to be at a distance, at a particular distance from a plane over here, and that one doesn't exist. So that's why this is being problematic. So what I want is a perpendicular plane to this, passing through the center of the shaft. So let's go back to our base part, and I'll make a plane which passes through this axis and is perpendicular to this plane. So I've selected this axis, selected this plane, holding down control. Let's make a new plane, and yeah, that's what I want. I want it to pass through the axis, and I want it to be offset angularly at an angle of 90 degrees. And I'll decrease its display size. Now I have this plane, and you'll see what I'm trying to do is that I'm trying to have the offset distance between this plane and the back of the second hub to be 1.25, the mounting distance. Sorry. So let's quickly repeat some of the steps that we just started. We are defining a pin joint. Let's bring our gear a bit closer, orient it generally in the right orientation, define the axis of rotation. Okay, I did not specify that I want a pin joint. Define the axis of rotation, and then define the translational constraint from the back of the gear to this plane that we just created, and we want it not to be coincident but at a distance of 1.25. So opposite of that, so minus 1.25. And now if you look at things perpendicularly, and I'll get rid of the planes over here, you'll see that the 2 points that we created, it might look like 1 point, but there are 2 points, one for each gear. They are coincident. We do not use that point to assemble our things, but we are using that as confirmation that we use the correct mounting distance. And what we'll do now is that we'll set the starting point position of our gears before we define a gear connection. This generally looks reasonable to me. You can always try to do slightly better, and you can check for interference as we've discussed previously. But this generally looks like the kind of gear assembly that we'll need, where you have two bevel gears intersecting with intersecting axes, and they should be able to transmit power perpendicularly. Now, similar to how we defined a spur gear connection, we'll go to mechanism, and uh, we will define a gear connection from here. We'll select bevel gear. The pitch diameter for our gear is 1.25 inches. You can get that from the data sheet on McMaster-Card, 1.25. I'll specify that. Here the pitch, for first we'll define our first gear using its axis. Here this is our first gear. The pitch diameter is 1.25, and next we'll define our second gear using its axis, and we'll verify that it is connected in the right arrangement. Right now it's not, because if you look at this icon for your second gear, it has two problems. One, it's too big, and second, it is facing the opposite way. We'll fix the size problem later, but first let's make it oriented in the right way. So now when you move it clockwise, this will move counterclockwise as it should. So Creo automatically calculates the pitch diameter, and it's incorrectly calculating the pitch diameter of this gear as 2.5. You can fix that by moving the location of your first gear as Creo understands it. So right now, for whatever reason, Creo thinks that your first gear is over here where you see this green icon. You can change its location by selecting this arrow and selecting a point through the center of this gear. And when you do that, you'll see that the pitch diameter over here should be 1.25 as well, but that's a lot of work. An easier way to get around that is not to ask Creo to determine the pitch circle diameters, define it manually. The pitch circle diameter of gear 1 is 1.25, and so is it for the second gear. And once we have done that, we have to verify that our pressure angle is correct. For our case, it is. I know it from the specifications on McMaster-Card, but you should verify that. We don't have any helical angle. It's a straight bevel gear, so that's correct. And the other properties are calculated for us. Then I'll click OK, and we have established a bevel gear connection. You can close the mechanism application, and now when we move our first gear, the second gear moves with it, and our mating is consistent, and this depends on where you set your first tooth to mate. In this way, you can make a bevel gear assembly, and motion which might have been transmitted to this shaft, for example, through a spur gear, is now being transmitted downstream at a 90-degree angle. Thank you for watching this video.